Bismillahirrahmanirrahim. Students, today we are going to discuss class 9th, chapter number 2, structure of atom. My topic is electronic configuration. This is a clear-cut topic given at the page 36. So last time we discussed the uses of isotopes. Now we are going to discuss electronic configuration. What is the electronic configuration? Electronic configuration is a process by which electrons are distributed in subshells on the basis of increasing order of energy. This process called electronic configuration. So electronic configuration is an art which deals with the distribution of electron in shells and subshells on the basis of increasing order of energy. So by this, matter is composed of atoms. Atoms have a central part which is called nucleus and also have shells where electrons are present. So this is the main topic, electronic configuration. This topic is further divided into three subtopics. One is shell, also called orbits. Other is subshells, and the third is the electronic configuration of first 18 elements. So let us start with the shell. Shell, also known as orbits. According to the concept of shell was first time introduced by Bohr. According to Bohr, electrons revolves around the nucleus. This is nucleus, red color. This is nucleus. This is the first shell, second shell, third shell. Electrons revolve around the nucleus in fixed circular paths. These circular paths in which electron revolve around the nucleus are called shells or orbits. The energy of electron inside any shell is constant. I mean fixed. That's why each shell or orbit is also called energy level. It is also called energy level. Why it is called so? Because energy of each electron is fixed or constant as far as that electron remain in a particular orbit. It neither releases nor absorbs energy, so its energy is conserved or constant or fixed. So that's why each shell or orbit, another term, is also used for the same thing, that is energy level. So shell or orbits are also called energy levels, in some books main energy levels. So energy levels starts from immediately after nucleus. This is called the first shell, and shells are represented by small n. N is equal to 1. It is also given a symbol called K. So we will also call K shell. So remember that, students, this is K shell, also called N is equal to 1. N is the number of shell. So the first shell is also called K shell. Similarly, this is the second shell. So it has number n is equal to 2. It is called, when n is equal to 2, it is called L shell. And when n is equal to 3, for this n is equal to 3. This is called M shell. If any atom has further more shells, so they will be designated by the symbol N, O, P, and so on. Almost so far the atoms which have been discovered so far, they have up to 7 shells. So N represents the number of shell. N is equal to 1 means first shell, it is represented as K shell. N is equal to 2 means the second shell after nucleus. So it is represented by L shell. N is equal to 3 means third shell, and it is been designated with the symbol M. So K, L, M, N, O, P, these are the symbolic representations of shells. Let me explain something also here which is not given in your book, but this is important. Remember that how many electrons can be accommodated in a particular shell. Bohr introduced a formula for this, which was 2n square. 2n square is a formula for determination of the number of electrons that can be accommodated in a particular shell, where n is the number of shell. For example, how many electrons can be accommodated in the first shell? And you know, for first shell n is equal to 1. So put n is equal to 1 here. You will get 2 into 1 square. 1 square gives us 1 multiplied by 2. So it gives us 2. So 2 electrons are accommodated in the shell. So first shell can accommodate maximum of 2 electrons, never more than 2. Yes, they can be less than 2. For example, in hydrogen there is a single electron, so the first shell has just 1 electron, nothing else. Helium has 2 electrons. If an atom has 3 electrons, then the next electron will go to the higher shell. So if we put 2 for the second shell, let's say if we are going to determine that how many electrons can be accommodated in the second shell, then put 2 instead of n. So when we put 2 square gives us 4, 4 into 2, so 8 is the answer. So the first shell can accommodate 2 electrons, while the second shell can accommodate 8 electrons. Similarly, if we want to determine that how many electrons can be accommodated by the third shell, so put 3 instead of n, and 3 square gives us 9. 9 multiplied by 2, it gives us 18. So third shell can accommodate 18 electrons. Similarly, fourth shell can accommodate 32 electrons. Fifth shell can accommodate 50 electrons. And similarly, the sixth shell can accommodate 72 electrons, and so on. So this was something about the shell, also called orbits or energy levels. How many electrons that a particular shell or orbit can accommodate. I have discussed this. Now let me proceed towards subshells. So what are the subshells? So now we are going towards the next subshells. This is the next subtopic under the grand topic electronic configuration. We have discussed shells. Now we will discuss what are subshells. Remember that there is no clear-cut definition of subshell in your book, but you can write that subshells are actually, these are the assemblies of orbitals, also called orbitals. So subshell is a space or region around the nucleus where the probability of finding electron is maximum at any point, at any instant, at any time, for example. So subshells are what? Subshells are the region or space around the nucleus where the probability of finding electron is maximum. So this is the definition of the subshell. You can also write in your book. So please write, because there is no clear-cut definition of the subshell. What is a subshell? Subshells are actually, these are the assemblies of very important term, orbitals. So orbitals are not given or not mentioned in your book, but we shall just confine ourselves to subshells. Remember that there are various subshells. One is called S, other is called P, other is called D, the last one is called F. G and H are also reported, but they are out of the scope of this book. Remember that S subshell can accommodate maximum of 2 electrons. P subshell can accommodate maximum of 6 electrons. D subshell can accommodate maximum of 10 electrons, while the F subshell can accommodate maximum of 14 electrons. And remember that what these symbols stands for, actually these were actually on the basis of the behavior of the spectral lines which were obtained by scientists during their spectroscopic studies. S for sharp, P for the principal, D for diffused, and F for fundamental. Sharp, principal, diffused, and fundamental. So now always remember that how many electrons can be maximally accommodated in a particular subshell. So these are the subshells S, P, D, and F, and they can accommodate 2, 6, 4, 10, and 14 electrons respectively. And each shell has one or more subshells. Just like if you have a house, if the atom is you can say if a shell is a house, then subshells are the rooms in that house. For example, if we want to construct a house, if we call it K, and you know, if K is a shell, it can accommodate maximum of 2 electrons. So what room will be constructed for this purpose? For example, for K shell, which can accommodate 2 electrons, which room is sufficient? You know, S. So it will just have one S, one for the first shell, S for the subshell, and the number of electrons, which are the number of passengers what you are going to accommodate in that house. For example, shell is a house, subshell is a room, and similarly the number of passengers they are acting as electrons. So first shell has a subshell S, and it can accommodate maximum of 2 electrons. Now you know second shell, which was known as L shell, and remember that, if you remember, L shell was able to accommodate 8 electrons. So how many rooms we will need here? So for this house we have to construct 2 types of room. You know, one is S, which will accommodate 2, and P will accommodate 6. So 2 plus 6, it will give us 8. So as we are talking about, this was n is equal to 1, and this was the second shell, n is equal to 2. So we will write 2 here now. So we will need 2S room and 2P room. So S again can accommodate. So this represents the number of shell, this is the type of subshell, and superscript represents the number of electrons. So 2s2, 2p6, 2 plus 6 equal to 8 electrons. Similarly, if we take n is equal to 3, this is called M shell. It can accommodate maximum of 18 electrons. So if you have a house in which you are going to accommodate 18 individuals, so what types of room you have to construct or you have to use? For example, for 18, look at this figure. 2 plus 6, 8, 8 plus 10. Yes, this constitutes 18. So I will use all of these three rooms. It's the third shell, so I shall write what? 3 S. Similarly, 3 P and 3D. S can accommodate maximum of 2, P 6 and D 10. 2 plus 6, 8, 8 plus 10, 18. So this is for 18 electrons. So in this way, we can put some more electrons and we can proceed further, but there is some confusion in this order because 4s has lower energy than the 3d, so that's why we will not follow this order. I shall draw a special diagram and you have to follow that diagram while writing the electronic configuration. So if someone asks that what is the difference between the shell and subshell, this is your homework, but you have to write it and then show it to me. But before going into the detail of this, let me say something about this difference. You may write these points as well. What is a shell? The circular path around the nucleus where the electrons revolve according to Bohr atomic model. So this is called an orbit or shell. So what is an orbit or shell? The circular path around the nucleus where electrons revolve. What is a subshell? Subshell are the region or space around the nucleus where the probability of finding electrons are maximum. Subshell are actually nothing but they are assemblies of orbitals. Orbitals are very important, but they are out of the scope of your book, so that's why I am not using the term orbitals. I shall just confine myself to subshell. So on the basis of definition, you can differentiate that this will be the first difference. Similarly, you can write this that shells are flat. They are flat structures, while and unidimensional, while the subshells are not flat, they are three-dimensional structures. So shells are unidimensional and subshells are three-dimensional. Similarly, shell is flat, but subshells are not flat. Similarly, shell, the number of electrons that can be accommodated in a particular shell can be determined by the formula 2n square, and according to 2n square, the first shell can accommodate 2 electrons, the second shell can accommodate 8 electrons, the third shell can accommodate 18 electrons, but the subshells can accommodate, the S can accommodate 2, P can accommodate 6, D can accommodate 10, F can accommodate 14 electrons. Subshells are also called sub-energy levels, while the shell is called main energy level. So actually similarly you can also write the types of these. For example, shells are represented by n is equal to 1, or they are represented by K, L, M symbols, and subshells are represented by S, P, D and F. So write at least 5 points for the difference between the shell and subshell, and this question is very important from examination point of view. Now we are proceeding towards the third topic, which is the electronic configuration of first 18 elements. You can check this topic at the end of this chapter. So the next topic is the electronic configuration of first 18 elements. So now let's start with the shell. First shell can accommodate 2 electrons. So I shall write just 1s because S can also accommodate 2 electrons. The second shell can accommodate how many electrons? 8. So what subshells are to be used? 2. So this is the second shell, so write 2s and 2p. Similarly, what about the third shell? Third shell can accommodate maximum of 18 electrons. So for 18 electrons we shall use S, P and D. Stepwise move ahead, one or increase one subshell number by number. So now 3S, 3P and 3D. First was 1S, then 1S 2P, then 3S 3P and 3D, and the next we will move towards F. So here 2 electrons and 6, 2 and 6, 8 plus 10, 18. So the third shell can accommodate maximum of 18 electrons. So these are on the basis of, I have written these subshells on the basis of number of electrons accommodated by a particular shell. Similarly, 4s, 4p, 4d, 4f. Proceed. Likewise, 5s, 5p, 5d, 5f. So similarly we can write 5s, 5p, 5d, 5f, 6s, 6p, 6d, 6f, 7s, 7p, 7d, 7f. Now I shall draw some arrows over these subshells. First of all, over 1 1 subshell, then over 2 2, then over 3 3, and finally 4. Look at this sequence: 1 1, 2 2, 3 3, and finally 4. How? Look at me. 1 subshell, 1 subshell, 2 subshells. Similarly, 2 subshells. Draw the arrow over 1 1, 2 2, then 3 3, and finally over 4. So I have drawn arrows over 1 subshell, 1 subshell, 2 subshell, 2. Look at this, the arrow over 2 subshells. This arrow is over 2 subshell. The next is over 3. Again over 3, and finally the 4. If you can draw this structure, you can write, you will be able to write the electronic configuration of any element. But remember that how to proceed along with this diagram, always remember that how to proceed with this diagram. Now look at me. Always comes from the head of one arrow to the tail of the next. Never come like this. For example, how I shall proceed? From 1s, then go back. From back side. 2s, not to the 3s, never. Go to the back of the arrow. 2p, then 3s. From 3s, never the 4s. Go to the back side again. 3p. Then 4s. From 4s, never the 5s. Go to the back side. 3d, 4p, 5s, and so on. Let's say if someone gives us a symbol of an element that write its electronic configuration, for example, Na. This is the symbol of sodium element. And I have discussed many times that for any element at the left bottom side or at the subscript side, left subscript, atomic number is shown, while at the left superscript side, mass number is shown. Now, for example, in paper we have a question that write the electronic configuration of sodium. But ignore this one, take this one. This represents the atomic number, and atomic number is the number of electrons present in a nucleus, in the neutral atom. So atomic numbers give us number of electrons, not the mass number. This is the sum of the proton and neutron. So most of the students do this mistake. But remember that one care must be taken that in your book, periodic table present in your book, the atomic numbers are shown at the top of the each symbol. So this develops some confusion. But remember that when electronic configuration is required, then symbolically this is the correct symbolic representation. And in your book, in periodic table, atomic numbers are mentioned at the top of each symbol of element. So never get confused. Your atomic number is this, and this will be in your paper. So here the sodium has atomic number 11. Now how we should proceed now? I have 11 electrons. So how to complete the 11 electrons? I shall start from this. 1s, and you know how many electrons can be accommodated in S? These are 2. So first shell S subshell has 2 electrons. 1s2, comma. 1 is the number of shell, S is the type of subshell, and superscript shows the number of electrons. So these are the number of electrons. So 2 electrons are accommodated. Now I shall proceed towards the next. So come head of the first with the tail of the next. 2s. So 2, again we know S can accommodate 2 electrons. So we will get 2s2. Now never come towards 3s, but the head of the one with the tail of the next. Yes, this is 2p. The next is 2p. But how many electrons can a p shell accommodate? Look at this here, 6. So 2p, 6. But also you must be careful about the number of electrons. How many electrons we have accommodated? 2 plus 2, 4 plus 6, 10. So we have accommodated so far 10 electrons. How many electrons are there in total? 11. So the next subshell will have just 1 electron, because we don't have the more electrons to accommodate. We have accommodated 10 and total are 11. So just the next subshell will have only 1 electron. Forget about that how many electrons it can maximally accommodate. So the next is where is 2p? Where is 1s? Then we proceed towards the 2s and towards the 2p. After 2p, where we will go? 3s. So 3s, and total number of electrons are 11. How many we have accommodated? 2 plus 2, 4 plus 6, 10. How many left? 1. So just write 1 here. So this is the electronic configuration of sodium atom. If someone asks that, write the electronic configuration of oxygen. Oh, oxygen has atomic number 8. What will you do? Again start from 1s2, 2s2, how many electrons? 4. And 2p, yes, you have 8 electrons, so you have accommodated 4. And it can accommodate 6, maximum of 6. So write 2p, 4 here. The last subshell can accommodate any number of electrons. This is not necessary that it must always have 6 electrons. No, it can have 1, 2, 3, any number. But remember, this must also be remembered that now why I have drawn this order. This is known as Abba principle. This is called Abba. Some people call it Abba. Some people keep the F silent. Abba's principle. Whatever you call it, this is the principle on which I have arranged these subshells. And remember that this is the increasing order of energy of subshell. the energy of 1s is less, 2s is has greater energy than 1s. Similarly, 2p has greater energy than 2s, and the energy of the 3s is greater than 2p. From 3s we will proceed towards the 3p. The energy of 3p is more than 3s. So this is actually the increasing order of energy of subshells. So what is the electronic configuration? Electronic configuration is the art dealing with the distribution of electrons and subshells on the basis of increasing order of energy or on the basis of Gauss principle. So each next orbital has greater energy than the previous one. So as we move ahead, the energy of the orbital increases. I mean energy of electrons and those orbitals increases. So this is the increasing order of energy of orbitals. So let's say if someone asks that write the electronic configuration of chlorine, symbol of chlorine is Cl, its atomic number is 17, mass number is 35. Now I am going to draw its electronic configuration. Again, this atomic number shows the total number of electrons. So I have to accommodate 17 electrons in total. So again start with 1s, 1s, s can accommodate 2 electrons, then towards 2s, 2s can accommodate electrons, 2, then from 2s go to the tail of the next 2p, 2p6. Keep in mind how many electrons you have distributed so far. 2 plus 2 plus 6, so 10. Total are 10. We have total of 17. So move ahead from 2p to 3s. Again s can accommodate 2 electrons. From 3s to, how many electrons are in total now? 2 plus 2, 4 plus 6, 10 plus 2, 12. So for 12, total are 17. So again move ahead. Now from 3s to 3p, how many electrons are left? 2 plus 2, 4 plus 6, 10 plus 2, 12. So 5 are left in order to complete 17 electrons. So I shall write 3p5. Again, this is the electronic configuration of chlorine. The next element with atomic number 18 is argon. In argon, we have electronic configuration similar to chlorine, except 3p5 is 3p6. Similarly, if they give you sulfur, sulfur has 16 electrons. So for 16 electron, what will you do? 2 plus 2, 4 plus 6, 10 plus 2, 12. So 3p will have 4 electrons. If someone says that give the right electronic configuration of phosphorus, P, which is 15, atomic number 15. So for 15, 2 plus 2, 4 plus 6, 10 plus 2, 12. How many electrons are in total? 15. So if I write 3 electrons here, this will constitute 15 electrons in phosphorus. So you can write the electronic configuration of any element by using this diagram. This will be very helpful for you in your first year. There are some self-assessment exercises given in your book. So check the atomic number and write the electronic configuration. If you have any query, you can discuss with me. You can call me through WhatsApp. Whatever do you need and do you consider appropriate, you can call me. Okay, so I thank you all. This was something about electronic configuration. Thank you.